Hi guys, welcome back. In the last video, I introduced you the concept of numerical solutions of equations, where we discussed that there are certain equations which cannot be solved directly or by some usual algebraic methods. So there are certain indirect methods which gives you an approximate solution of the equation. So within that, we discussed the method which is called the change of sign method. Within change of sign method, there were two methods that can be used in order to arrive at any approximate solution. Number one was using a decimal increase method, means you have been given an interval and you move throughout the interval by increasing the decimal point by 0.1. Suppose the root was, you know that the root is lying between 0 and 1. So to arrive at an approximate value of that root, you start moving from 0 towards 1 by increasing the interval by 0.1. So next value will be you took 0.1, then you took 0.2, 0.3 and so on. And then look where the function is changing its sign from negative to positive or from positive to negative, right? And then again you divide the interval by 0.1, means you increase the decimal by 0.01. Once you have looked, let us say you arrive at a solution which is that the function is changing its sign from 0.6 to 0.7. So to arrive at more accurate solution, you increase now this interval 0.6 and 0.7 by 0.01. So next point you took as 0.61, then 0.62 and so on. In this video, and second was bisection method, that you divide the whole interval into two halves by finding out the midpoint, and then again look for the change of sign at the initial point, then at the midpoint, or first you took the midpoint and the last point, right? And then look for the change of sign and again divide the interval into again two halves, right? And you keep on dividing the interval into two halves and you arrive at the solution, approximately solution. Okay. Today we are going to discuss some problems with change of sign methods. What are the drawbacks that are inherent in using change of sign method? First is that if the curve touches the x-axis. So if a curve is touching the x-axis, that means we have a root here. This value is your root alpha. Okay, for example, you are saying this root as alpha. But if you go using change of sign method, for all the values which are less than alpha, my function is positive. For all the values which are greater than alpha, again the function is positive. So there are chances that you miss this root alpha, right? So you will miss this root alpha. This is one drawback. Second is, if there are several roots which are very close together. Suppose you have been given that this equation, this function fx equal to x cube minus 1.9 x square plus 1.11 x minus 0.189. This is one function and you have been given that there is a root which lies between 0 and 1. So here, as you can see, the graph of the function this fx is drawn. Since it is known that the root is lying between 0 and 1, using any method, whether bisection method or decimal increase method. Suppose you are using decimal increase method and you find out the value of the function at 0.1, 0.2, 0.3 and 0.4. So you will arrive at a root that the function is changing its sign from negative to positive for all the values of x which are less than 0.3 and for greater than 0.3. So you arrive at a solution that there is a solution of 0.3 which is lying between 0 and 1 because the function is changing its sign from negative to positive. And then you will stop. What about these solutions which are again lying between 0 and 1? So there are certain chances that you miss all these other 2 points. Because once you have arrived at one solution which is between 0 and 1, so there are chances that you will go for another interval. You won't look for any other solution which lies within that same interval, like we have done in the previous or in the examples that I gave you in the introduction, right? So this is another drawback, or you can say the problems that are associated with change of sign method, that you may miss other roots which are in fact lying within the same interval, right? That means if the roots are very close together. Next problem is that what happens if the function is carrying some discontinuity or where the function is not defined. So here is the graph that is drawn of a function fx, which is fx is equal to 1 upon x minus 2.7, because it is a shifted curve of y is equal to 1 upon x, which is a rectangular hyperbola. It has just shifted towards right by 2.7 units. Since x is equal to, since when x is equal to 2.7, at this value the function is not defined, so we have a discontinuity at x equal to 2.7, right? So using the change of sign method, if you go for the values which are lying less than 2.7, you will say that the function is having negative value. Sorry, this is negative value like this. And if you take any value which is greater than 2.7, you will say that the function is positive, right? So what conclusion you can draw is that since for all the values less than 2.7 it is negative, for all the values greater than 2.7 the function is positive. That means function is changing its sign from negative to positive. So x equal to 2.7 is one root, but in fact it is not a root, it is a discontinuity. In fact, at x equal to 2.7, this is not lying in the domain of fx. Okay, so these three are the problems or the drawbacks that are associated with change of sign method. This you should keep in mind. Okay, next is we are going to discuss some problems, and we will arrive at some means how to find out the solution, or we will apply change of sign or decimal increase method by doing some questions. So first question is that we have to show by calculation that the equation fx is equal to x raised to power 5 plus x minus 1 is equal to 0. It has a root alpha which lies between 0 and 1. So let us find out, or we have to show that root is lying between 0 and 1. That means function is changing its sign from within this interval 0 and 1. So how we can show this? So we have been given an interval 0 and 1. Let us check the value of f0. What is the value of function at x equal to 0? By putting x equal to 0, you arrive at a negative value which is minus 1. Now put the other extreme value which is 1, the other end. So value of function at x equal to 1 is 1 plus 1 is 2 minus 1 is plus 1. It is positive. That means function is changing its sign from negative 1 to positive 1 within this interval 0 and 1. So you are damn sure that there is a root which lies between 0 and 1. Hence proved. Okay. Next, it says that by sketching a suitable pair of graphs, we have to show that the equation cos x is equal to 2x minus 1. It has only one root for x which lies between 0 and pi by 2. That means pair of graphs we have to draw. So let us sketch these two curves. This is my x-axis, this is x, this is y. Right? So one graph we will draw for cos x. Let us draw cos x between 0 to pi by 2. Okay. This is a graph for cos x between 0 to pi by 2, because at x equal to 0, cos x is 1, and at x equal to pi by 2, cos x is 0. Right? And second is a straight line, which is your RHS 2x minus 1. So its y-intercept is minus 1. So if we have to sketch this straight line whose y-intercept is minus 1 and slope is 2, it means it is going to be at x equal to 0, it is minus 1, so it is like this. And if you have to find out the solution of this, means what is the x-intercept by putting y is equal to 0. So y is equal to 2x minus 1. By putting y equal to 0, you will get x as half. So x-intercept is half, which is 0.5, and this is means I am finding out whether I have to draw the graph of y equal to 2x minus 1 like this, means below this pi by 2, or after this pi by 2. Since the value of pi is 3.14, so 3.14 divided by 2 is of course greater than 1, and this x equal to half is less than 1, so definitely my straight line will be like this, right? This point is minus 1, right? And we have to find out this solution. Point of intersection of cos x and 2x minus 1 will give me the solution of cos x minus 2x plus 1 equal to 0. Okay, by drawing these two separate graphs, I can find out the solution of fx, which is cos x minus 2x plus 1 equal to 0. Okay, so it says that it has only one root between 0 to pi by 2. Only one root means there will only be a single point of intersection of these two curves. As shown in the graph, there is only this point of intersection, single point of intersection between 0 to pi by 2 for these two curves. It means fx, which is fx equal to 0, has only one root between 0 to pi by 2. Right? Basically, you have to show that there must be a single point of intersection between the given interval. Had it been, if it is asking about, show that it is having 2 point of intersection between, let us say, another interval, so there will be some 2 point of intersections, right? Not in this particular question, right? B part says we have to verify by calculation that this root it lies between x equal to 0.8 and 0.9, right? That means since now we have a function which is fx equal to cos x minus 2x plus 1, we have to verify that there is a root which lies between 0.8 and 0.9. So now the work is very easy, means we have to find out the value of f of 0.8, which is cos of 0.8 in radians, minus 2 into 0.8, this is 0.8 plus 1. So cos of 0.8, I do not know the exact value of this. Let me see if I can find out the other value by other means. 2 into 0.8 is minus 1.6 plus 1 is cos of 0.8 minus 0.6, right? Let us find out at 0.9 what is the value of function. So f at 0.9 is cos of 0.9 minus 2 into 0.9 is minus 1.8 plus 1. So this is cos of 0.9 minus 0.8. So obviously this value, let us consider that this value is positive, then obviously the second value should come out to be opposite of this. So if cos of 0.8 minus 0.6 is positive, then cos of 0.9 minus 0.8 has to be negative, or vice versa, right? This will definitely come out like this. I do not have the calculator now to find out the value, exact value of this cos 0.8, but that will definitely be the case. Okay, so that's all for now. I will see you in the next video. There is a single topic which is remaining, which is the iteration process. Okay, thank you. I hope you will like this video. Bye bye. Take care.